In section 4.4, we'll be looking at exponential and logarithmic equations. An exponential equation is an equation containing a variable in an exponent. Solving exponential equations by expressing each side as a power of the same base. So if you have b to the m equals b to the n, in other words, both of these sides of an equation are raised from the same base b. So when you have the same base b, you can let the b's go, then set the exponents equal to one another. That's where we get m equals to n. So if we can ever get the bases to be the same on each side of the equation, then you can let the bases go and set the two exponents equal to one another. So rule number one, rewrite the equation in the form of b, base b to the m power equals base b to the n power. Next, rule number two, set m equal to n. Then rule number three, solve for the variable. So let's look at these first two examples that I have. Solve 2 to the 3x minus 8 equals to 16. This is an exponential equation because the variable is in the exponent. Now, your rule said raise both sides from the same base. Well, my left side is already raised from base 2. So we want to raise the right side from base 2 if possible. Now, the left side's already raised to the 3x minus 8. Now, let's think about it. 2 to what power gives you 16? Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That gives me 2 to the 4th. Okay? 2 times 2 is 4. 4 times that third 2 is 8. And 8 times that fourth 2 is 16. So we can rewrite the right-hand side from the same base as the left, raising both of them from base 2. Now, your rules say let the bases go and set the exponents, 3x minus 8 equal to 4. Now, when you do, solve for x. Add 8 to both sides. So you have 3x equals to 12, and divide both sides by 3, so x equals to 4. So your answer to this problem would be 4. You could check it by plugging it back in. 3 times 4 is 12. 12 minus 8 is 4. Is 2 to the 4th 16? Does the left side equal the right side? Yes, it does. Therefore, we know our answer is correct. Let's look at the next example. Again, this is an exponential equation. The exponent contains the variable. The first way that we always want to try to solve exponential equations is to try to raise both sides from the same base. Well, my left side already has from base 5 to the 3x minus 6. Can we raise the right-hand side from base 5 to some power to get 125? Well, think about it. 5 times 5 is 25. What's 25 times 5? Use your calculator. That gives you 125. So that would be 5 cubed is 125. We have raised both sides from the same base. Let the 5's go. When you let the 5's go, you set the two exponents equal to one another. 3x minus 6 equals to 3. Now you add 6 to both sides, you get 3x equals to 9. Divide both sides, you get 3x equals to 3. 3 is your final answer. You could check it by plugging in 3, your answer 3, back into x in the original problem. So this would be 5. 3 times 3 minus 6, does that equal to 125? That's your question. Well, 3 times 3 is 9. 9 minus 6 is 3. Therefore, is 5 cubed 125? So, yes, 5 cubed is 125. So, when the left side equals to the right side, then your answer is correct. So, the final answer for this problem would be x equals to 3. Now let's continue looking at a few more problems of solving exponential equations. With this problem, if we try to raise both sides from the same base, let's look at it. Well, I have this side raised from base 9. Can I raise 9 to a power and get 27? No. But what I do notice about 27 and 9, they are both raised from the base 3. We could think about 9, that's the same as 3 squared. When I think about 27, that is the same thing as 3 cubed. So both the 9 and the 27 can be raised from base 3. So therefore I'm going to start this raising both sides from base 3. Now what I'm going to do is I'm going to write 27 is 3 cubed raised to the x plus 3 power. I'm going to write 9 as 3 squared raised to the x minus 1 power. Now, anytime we have an exponent raised to a higher power exponent, we need to multiply these two exponents. Well, when you multiply the 3 times the x plus 3, thinking of that as a binomial, you're distributing. 3 times x would be 3x, and 3 times 3 would be 9. Over on the right-hand side, you're multiplying 2 times x minus 1. Again, you can think of it as distributing 2 times the binomial. That's 3 to the 2x minus 2. If you distribute 2 times x is 2x, and 2 times negative 1 is negative 2. Now we have them raised from the same base. Let the bases go. Set the two exponents equal to one another and solve for x. So let's subtract 2x from both sides. Therefore, I get 1x plus 9 equals to negative 2. So let's subtract 9 from both sides. So x equals to negative 11. So that problem was different from the fact that you could not raise both sides from the original bases that were given in the problem. You had to go back and think about 9 is a perfect square. It comes from base 3. 3 squared is 9, and 3 cubed is 27. So we raised them both from base 3, giving us a final answer of x equals to negative 11. Let's do another problem like that. Looking at this problem. Can I raise base 4 to a power to get 8? In other words, is 4 squared 8? No, 4 squared is 16. So both of these bases, let's think about, were they raised from the same base? When I think of 4, I think of it being a perfect square. 2 squared gives me 4. So I can rewrite 4 as 2 squared, and I can rewrite 8 as 2 cubed. 4 is a perfect square. 8 is a perfect cube, but either way, both of them are raised from base 2. So let's raise both sides here from base 2. 8 is 2 cubed raised to the x plus 2 power. 4 is 2 squared to the x minus 3 power. Now what you want to do, multiply these exponents together. That's your exponent rule. An exponent being raised on to a power, another exponent, you multiply them together. So we get 2, distribute here. The 3 times x plus 2 would give you 3x plus 6 equals 2. On the right-hand side, distribute. 2 times x minus 3 would be base 2 to the 2x minus 6. When the bases are the same, let the bases go and write the exponents equal to one another. Set those equal. Now solve, subtract 2x from both sides. So I have 1x plus 6 equals to negative 6. So let's subtract 6 from both sides. I have x equals to negative 12. So your final answer for that problem is x equals to negative 12. Now let's look at this next example. 4 to the x equals to 15. Again, this is an exponential equation. We want to try to raise both sides from the same base. Well, your smallest number is 4. Can we raise the right-hand side? Is 4 to a power ever going to give me 15? No. Next we think about, is 4 a perfect square? Yes, I could raise the left side from base 2, but could I raise the right side from base 2? No. Therefore, this is a new type of problem. When you can't raise both sides from the same base, we will take the ln, or the ln, of both sides. So let's take the ln of 4x and set it equal to the ln of 15. When you can't raise both sides from the same base, you will take the ln of both sides. Now we have an exponent. So the next thing we will use is our power rule. To solve for x, you use the power rule. You bring it to the front. That would give us x, ln 4, equals to ln 15. Keep in mind, on an equation, you're solving for x. So we need to divide. To undo the multiplication of ln 4 times x, you divide both sides by ln 4. The ln 4's cancel, so you end up with x equals to ln 15 divided by ln 4. Now, that could be your final answer, depending on how the online homework tells you to leave your answer. You could put this in your calculator. ln 15 divided by ln 4, and your final answer would be approximately 1.95. So to obtain the final answer, you would have to use your calculator of ln 15 divided by ln 4. If they told you to round it to the nearest hundredths, that would be your final answer. If they don't say round, you can leave this as your answer, but if they tell you to round it to the nearest hundredths, the 1.95 would be your final answer.